Two forces, 4a minus 2j and 2i plus qj, act on a particle P of mass 1.5 kilograms. So let's write F1 equal to 4i minus 2j, F2 equal to 2i plus qj. The resultant of the forces, we simply add the two vectors. So the resultant F equal to F1 plus F2 equals 6i plus q minus 2j. We're told this resultant is parallel to the vector 2i plus j. So it's a scalar multiple of 2i plus j. Put it equal to lambda times 2i plus j. If we equate the I components on both sides and the j components on both sides, we see that 6 equals 2 lambda, so lambda equals 3, and q minus 2 also equals lambda, so q equals 5. At time t equals 0, p is moving with velocity minus 2i plus 4j. We have to find the speed of p at time t equals 2. So it's accelerating because there's a force acting on the mass of 1.5 kilograms. And we know this force equals the mass times the acceleration. The force F equals 6i plus 3j. That's the value when we substitute q equal to 5 into this equation here. So 6i plus 3j equals the mass, 1.5, times the acceleration vector a. From this we can see that a equals 4i plus 2j. Now we use v equals u plus at in the vector form to find the velocity vector at time t equals 2. So the velocity vector equals the initial velocity minus 2i plus 4j plus t times the acceleration vector plus t times the acceleration vector. So when t equals 2, it will be 2 times the acceleration vector 4i plus 2j. So v equals 6i plus 8j. We want to find the speed at time t equals 2 seconds rather than the velocity. The speed's the magnitude of the velocity vector. To calculate this, it's simply Pythagoras, and here in fact we have a 3, 4, 5 right-angled triangle. So the speed at time t equals 2 will be 10 meters per second.